Welcome to the second part of this video. Okay, at the end of that video, I was just saying that the prediction of P3 using P3 twice using the two components of production system gives us these curves. This is the end of part one. Okay, and then we go for part two. Part two, we're gonna use the Gilbert. So before using Gilbert, I would like to tell you how we get the delta P, the pressure drop between these two curves. Okay, so basically I go for let's say 200 bars per day, and then I get the difference between this and this. I find it 497 psi. Okay, and then I do the same thing for 400 bars per day, which is lower, and it's 400, and I go for 800 bars per day, for example, and I get a smaller one, which is 127. Okay, these data, okay, the Q and the delta P is giving me this. Okay, so to have a wider range of the curve, I fit the line here. Okay, and then I used it to predict for higher or wider range of Q. Okay, this is Q. And this is the delta P using that trend line. Okay, so basically I use the trend line to get a wider pressure drop. Okay, which is I plot it here. Okay, that's all. Now the second part, this is the result of part one that I was talking in lecture. It's two parts, not two steps. This is part one. Now part two is to understand how you get these lines. Okay, to get these lines, we start with Gilbert wellhead pressure. Okay, the Gilbert wellhead pressure, we have, it was given to us to analyze or design select for different choke beam sizes, 16, 20, 24, 28 of 1 over 64th of an inch. Then we start by choosing Q, 300 to 600 parts per day. And then if you remember what I said to you, for a larger beam size, you shift to a higher range of the flow rate. So instead of starting from 300, we start 400, and we end up 900. Okay, the same thing here. We start from 500, and we end up in 1,100. Here we start from 600, we end up in 1,200. But the point is, we use Gilbert to get the pressure drop. Here, the constant C multiply R, okay, reference to the lecture, to the power of 0.5 by Q divided by 16 to the squared. Okay, so here you get the delta P. You get the P wellhead. Okay, the P wellhead to drive the flow from the wellhead through the choke, through the flow line, and overcome the pressure separator. Okay, for all the beam sizes. Now, we have to get the downstream pressures only, means after the choke. To do that, I used, I fitted the trend line over here, okay, for the downstream component of the production system. I used it, and I calculated using the Qs. Of course, the Qs corresponding, using the Qs corresponding to 16, okay, because here I'm predicting the 16 beam size, okay. So you get the downstream of the choke pressure drop. For 20 beam size, I use Q of the 20 beam size that I assumed. Same thing for 24, same thing for 28, okay. Same thing for 28, I use these flow rates to predict the downstream choke. So now we have in here we have, for example, for the bin size 20, it predicts that Gilbert predicts analytically that the P wellhead should be 395 psi to circulate your fluids, oil and gas, from through the choke, through the flow line, and overcome the separator. But the delta P that we got from here, from part 1, it's only through graphically, that we got graphically, it was through the choke only. So you have to take out from this big pressure the after the choke until the separator to get only the delta P through the choke analytically, which I did here. Okay, so over here for 16, okay, these are the delta P, okay, delta P analytic, all right, and these ones are delta P, okay, delta P graphic. So you calculate this delta P analytically, okay? For example, here the 20 bin size. You go to the 20 bin size from Gilbert minus the P downstream choke, okay? You get these, and then you plot them. So you plot these delta P's, okay, with the assumed Q for each bin size type, okay? Let me see it. Here it is for this, okay, you can see it there, and for this one. Now, Ruhud said that last time, today she said, what's the point? Now, the point is now, okay, the point is now how you use it. So let's say your production manager is saying to you, look, we're planning to buy a choke of 20, of bin size 20, 1/64 of an inch. Can you predict, as a production engineer yourself, can you predict what would be the flow rate? You do this analysis and you say, look, if we're going to use the bin size 20, then our flow rate would be less than 600 bars per day. And then he says to you, oh, we would like to have more than 600 bars per day. Then you say, okay, if we go for 24 bin size, then you get more than 700 bars per day. If you go for a bigger bin size, then you get a bigger flow rate. But if you go for smaller bin sizes, then you get eventually, because of big restriction, you get less flow rate. Okay, so that's the big point. All right, so this I hope it made a little sense to you guys. And what I would like to ask you now is to make homework 5 by replicating this video, means this Excel. I want you to upload on a Dropbox homework 5, the Excel, and explain, okay, with explanation, all right, that you understood. Thank you very much.